So about 6 months ago, after getting a couple viewer requests about it, I reviewed the AFERY P210 power station, which is a 2400 watt, 2048 watt hour mid-range kind of a budget power station. And in that review, I found the P210 to be a surprisingly solid power station, and I characterize it that way because the P210 performed very well in my spec testing. It seemed to have pretty solid build quality, and yet is priced at a fairly jaw-dropping 30 cents per watt hour. And as you would expect at that very low price, there were just a couple of compromises in that it lacked battery expansion options. The AC and solar charging performance was, I would say, adequate. Maybe not a standout spec for that class of a power station, but certainly adequate. Well, now AFERY is taking it up a notch and expanding their product line by introducing the P280. This guy right here. Just making sure that screen is still bright. And this thing has a form factor that's basically the same as the P210 as far as I can tell, and it has the same 2048 watt hours of rated battery capacity as the P210. But this P280 does have battery expansion options up to 10 kilowatt hours if you max it out with 4 of these 2048 watt hour expansion modules, and it steps things up a bit in several other key specs as well. So instead of a 2400 watt continuous output, the P280 is rated for 2800 continuous. And instead of 1100 watts of AC charging, this guy can do 1800 watts of AC charging. And as you'd hope, given the additional battery expansion options, this P280 has much more solar charging capacity as well, giving you 2 separate XT90 little solar ports right here that can take each 600 watts, so 1200 watts total. And that should allow you to fully charge this P280 with 1 battery expansion module in less than a full day of decent sun conditions. And given that the max expanded capacity is 10 kilowatt hours, AFERY has thoughtfully included a TT30 over on this side, right over here next to the other 3-prong AC outlets. So you can easily connect this to an RV or camper, or as we'll see in a bit, you can actually connect it to a manual transfer switch and you actually use it for home backup power, at least for a few of your critical circuits, up to a max of about 23 amps. And to quickly hit a few other notable specs, this P280 does have a 12 volt 25 amp XT60 connector output right here, if I can get the thing off, right there, which is convenient for powering a variety of DC appliances that might require more than your typical 12 volt 10 amp car socket can deliver, which of course it has one of those as well. And then it does also have 2 DC 5521 accessory ports and a PD 140 watt USB-C connector, which is super handy for fast charging laptops like this and tablets, without needing to bring along that big extra AC adapter for that. And to wrap it up, it weighs in at a pretty reasonable 47.6 pounds, and it is 15.6 inches wide. It is 12.4 inches tall and about 11 inches deep, and it is backed by a 2-year warranty. And I will say that 2 years is getting to be, I would say, on the short side these days for warranty periods, with more companies now offering 3, 4, or maybe even 5 years. Realistically, I think like with most complex electronics, most problems, if they are going to occur, typically occur in the first few weeks of use. So, I don't think that a 2-year warranty should necessarily be a deal breaker, provided that the build quality is sufficiently decent. Okay, I think that gives you a solid picture of where this unit sits as far as the specs go. So let's go run this thing through the paces and see how it performs. All right, as you can see, we are fully charged on this ginormous display. And let's go ahead and apply a load to this. We're going to do an AC discharge capacity test, and on this rated 2800 watt continuous AC inverter, a 0.2C discharge rate, which is the industry standard for capacity testing, would be, so if you take 2800 times 0.2, that would give me about 560 watts. So I don't think I'm gonna get 560 watts exactly, but probably be closer to 600. But let's go ahead and apply that load. Turn on the AC inverter, and before we apply a load, let's just check the output voltage here. And we are getting 121.6 volts, so that's excellent. All right, there, we're back on to watts. Let's go ahead and plug in a load. And I think we're going to get right around 600 watts. So we'll see what shows up over here. 626. I guess I could drop that down and let it run just a little bit longer, so it'll run slightly below 0.2C. All right, so pretty close. All right, so we're within about 30 watts of 0.2C. So let's let this thing run all the way down till the BMS shuts us down. We'll find out how many watt hours we actually record on this P280. All right, our AC discharge capacity test seems to be done. Let's just try to turn this on and see what we've got here and whether or not we're at 0%. Yep, 0% state of charge. So let's disconnect this, plug this into grid power and see how many watt hours we actually got out of that rated 2048. So we got a very respectable 1,850 watt hours. So that is that's above average at right on 90% of rated capacity. So very good usable capacity numbers. All right, let's do our DC discharge capacity test on this P280. I've got it fully charged back up. I've got this set to 10 amp draw. Let's go ahead and turn the DC outputs on. We can see that display brightens up very nicely. You can see that we're currently reading 13.68 volts, which is very good. So let's go ahead and start the test. See if it can maintain 10 amps. We have dropped to 12.5 volts. I actually like that. So clearly sustaining 10 amps, no problem. It says it's going to run for about 14 hours. We shall see. Now this is rated for 2,048 watt hours. So let's find out how many usable watt hours we can actually get if we're only discharging out of this 12 volt 10 amp port. Looks like our DC discharge capacity test is done. Real quick, we'll check and make sure we are in fact at 0% state of charge. And we clearly are. So let's zoom in and have a close look and see what we got. All right, as you can see in that little middle number there, we got 1,749 watt hours. That's out of that rated 2048. So that is actually a very respectable high side average, maybe a little above average, of 85.4% of the rated capacity out of the DC port by itself. I've noticed a lot of the DC capacity tests I've been running lately have been producing lower numbers, so it's nice to see that we're still getting a solid 85+% out of that DC port. So super happy with that. All right, now we're going to do the wake and charge solar test on this P280. Now it's got two XT90 inputs on the side, and those can handle 600 watts on each input. So 1,200 watts of solar total. And the voltage specs for those are 11.5 volts up to 55 volts max on each port. And both of those ports are capped at 20 amps, so it'll never draw more than 20 amps. Now I'm just using the one included XT90 solar cable that it comes with, and it's only about 1 meter long, so there's a good chance that you'd probably want an extension cable to go with this if you're going to be using solar. So this just barely reaches my solar connection down here, so I'm going to go ahead and turn that on. And we probably won't see any indication on screen that we're reading solar because it is almost 8 o'clock at night, so the sun is well down. It's quite dark outside. Now I basically connected two solar panels in parallel. So there's a 450 watt panel and there is a 395 watt panel. Now, both of those panels have a volts open circuit of about 49 volts, so that's under that 59 volt cap. And since they're in parallel, we don't add the voltage together, we instead add the amperage together. And the short circuit current on those panels is right around 10 to 12 amps, depending on the panels. So I think it's fair to call this about 800 watts, but as I said, this is capped. Each single port is capped at 600. So that's the max that we're going to get. We'll see if we actually get the max tomorrow. So let's check back in the morning and see if this thing will automatically resume charging in the morning on solar when the sun comes up without me having to do anything to it. See you in the morning. All right, it is 11:43 a.m. Let me brighten that screen up a little bit. If I zoom in there for you, you can see we are actually charging at 600 and just a couple of watts past 600. So the over paneling with those two 400 watt panels is definitely working, and we are getting the max input on just the single port. And we're already at 41%, which I find pretty impressive. Now I'm not sure if it's calculating the expansion battery in there as well or not, but it does. The expansion battery is giving me the charge LED animation. So I'm going to just let this run all day like this. We have pretty decent sky conditions, and it says 4 hours to a full charge. So let's see what we can do at half the input capacity that this thing is capable of taking from solar. And I'll check back at the end of the day to see where we ended up. All right, it is 6 p.m. And if I brighten that up, you can see we are not getting any more solar input now, which is normal because the sun is way down. The moon is actually pretty high in the sky. And we are at 92%. And apparently that does include the
expansion battery, because all of the 5 blocks are lit up. So we're very close to a full charge, even at only having half of the max solar input connected. Now keep in mind, we did over panel this at about 800 watts, enabling us to stay pretty much pegged through the peak sun time at 600 watts. So that's why we did so well. So that's very good performance out of the solar input on this P280. All right, let's do a noise test on the AC inverter of the P280 and find out if it would be suitable to be used as a remote power source for amplification applications like this guitar amp or PA systems or ham radios, that kind of thing. So we'll get a sense for how noisy or not the AC inverter output is. So let's get a baseline on grid power so we can hear how this particular amp sounds under grid power. All right, now per usual, I will have boosted that about 9 dB so you can hear it. So let's connect this amp over to the P280 and see if it sounds any different. All right, now I've got the amp plugged in over here on the side, and let's see if there's any difference in how it sounds. All right, so I heard just a slight additional amount of noise when powered off the P280, and that's going to sound a little bit more obvious to you because I will have boosted that volume for you. But in real time, in person here, that was not enough noise to give me any major concerns as a musician for using this for, certainly for voice amplification or for guitar amps and things like that. So that is a pass on the inverter noise test.
Checking the voltage on my solar input here. I want to make sure we don't go over 55 volts. And we are at 46 volts. So that's good. And so what I want to do is we're going to do a solar test for dual charging to find out if I can dual charge this via AC and solar at the same time and whether or not it will prioritize solar. So let me go ahead and get the AC charging going. And I'm going to let that count up because this is going to get us probably around 1700 watts. All right, looks like we have stabilized. And the reason I'm charging this with another power station is so we can actually see in real time how much power it's drawing from the AC power source, which is this guy over here. So just under 1700 watts. So let me go ahead and plug in the solar and see what happens. All right, connecting the solar. Let's see if this number climbs. Now this will cap at a maximum of 600 watts of solar. So it's got that voltage range of 11.5 to 55 volts, maximum 55 volts. So we're charging over 2000 watts now. And if we look over here, this has dropped. This was almost 1700 watts. And so it's basically allowing us to use as much solar as possible and then just supplement with the least amount of AC input that it can require. So it looks like dual charging is a definite pass, and it does prioritize solar charging over AC charging. So, pretty cool. Okay, now since this P280 has a TT30 outlet on it right here, I can actually use this as a backup system and power my barn off of this. And we're going to do this as part of the AC inverter load test. So I'm going to plug this little TT30 plug in here into the receptacle, and I'm going to turn the power on. And then this basically allows me to patch this P280 into my manual transfer switch, and I can start applying loads. So I have a power station plugged in my main office there. I'm going to switch that over to generator power, which is actually going to now take it out of that TT30 output. And keep in mind, because the P280 has a max continuous rated output on the AC inverter of 2800 watts, that's not going to give you the full 30 amps that that TT30 outlet can handle. It's going to give you about 23 and maybe 23.5 amps approximately. So that's the max on that port because of the limitation of the inverter being at 2800 watts instead of 3600 watts. But that's okay because we can actually work with that, and I can use that to power almost all the loads that I need to power in my barn here. So you can see I've got a load now that's pulling just a little over 160 watts. So let me go add some additional loads. Let's go ahead and do the utility room that we're in right now. We saw a little flash as that lighting gets switched over to here. And then I've got some high bay lights out there. Let's see, those are right there. That'll add about 1000 watts. All right, so now we are at 1457. Let's add a little bit more load. There's some stall lights. All right, now I've got a decibel meter up here that I'm going to turn on in a minute, and we're going to watch this. And I'm gonna go ahead and get this ready, because once we get this to the 2800 watt limit, we're gonna see if that'll run for a full 10 minutes. All right, so let's start taking this up and just see where this gets us here. All right, so this gets us to, it looks like we're still climbing. I think we've stabilized at 2600 watts here. Let me add a little bit more load. Another couple hundred watts. And we are now at 2821. Let's start the timer. All right, so 10-minute load test is a definite pass, and we stayed very much pegged right at 2800 watts, which is the limit. And interestingly, even though the fans are on right now, we never really got even to 51 decibels. So this is actually a nice and quiet power station. That is a pleasant surprise. Now the ambient temperature in this room, it's not very hot. It's about 65 degrees Fahrenheit, so it is pretty cool out. I imagine the fans might ramp up a bit if we were in, say, a 90-degree room, but at least in the environment that we're in right now, 50 decibels is about what you could expect, even running full out. And then taking a look at the watt meter, we are right there at 118 volts, which is nice. Let's go ahead and see how this thing behaves if we push it past the 2800. So let me add 100 watts, and we're going to watch the volt meter here while we do that. So I'm not sure if this does voltage throttling or not. It looks like it probably does, because we are stuck at 2800 watts and our voltage dropped to 110 volts. So yeah, what that tells me is that if you apply loads greater than 2800 watts, it is going to drop the voltage on you. And let's just see if I add another couple hundred watts, what it's going to continue to do. I imagine the voltage is going to continue to drop, even though it shows we're still steady at 2800 watts. And the voltage has dropped down to 108. So you want to try avoiding running this thing past 2800 watts with complex loads like TVs, refrigerators, air conditioners, computers, things like that. You don't want those to be starved with voltage. Anything down to 110 is perfectly fine. 108 is probably technically also fine, but anything past that and you're starting to stress those complex electronics. Let's push this just a little bit further, see how far the voltage will drop. And it doesn't look like we're going to drop any further. And at some point we would get an overload here. But I'm not sure what else I can throw at this thing. All right, so let me back this down and see if the voltage recovers. All right, so you can see we are back up to 120 volts. So as we inch that up, 2600 watts, we're still at 119. Call it 2700 watts, we're still at 119.6 volts, very good. All the way up to 2800 watts, and we are still holding pretty steady. We've dropped just a volt or two, and that's not a problem. And then if we push it well past that, then we'll see the significant voltage drop. So that's a configuration that a lot of power stations now have built in, including this one, and something you definitely want to be aware of. So you don't really want to try to run it past its rated continuous output for any length of time, because it will drop the voltage on you. All right, time to do the power tool test on this P280. I got the voltmeter up here so we can keep an eye on what kind of voltage drop we get on these various inrush currents. So I've got basically 3 different power tools, and I'll be escalating those in terms of how much inrush current they provide, or they demand from the 280, and we'll see what we can get away with here. So first up is my 3 horsepower 8-gallon shop vac. It's a Craftsman. It's got an inrush current of 27 amps and a continuous current draw of about 9 amps. So let me see if I can fire that up. This really should not be a problem for this power station, but let's just keep an eye on that as we turn the shop vac on. Here we go. I think we saw it drop to about 119.8 or 119.9 volts, but no problem running a shop vac. All right, so next up we have the 10-inch table saw. It's a Ryobi. It's got an inrush current of about 50 amps, so pretty significant jump from the shop vac in terms of inrush current. It has a continuous amp draw of about 6 amps. So let's see if it'll handle the Ryobi table saw. All right, so I think I did catch a momentary drop down to almost, I think it was 99 volts, which is a pretty significant drop. So it's acting as kind of a bit of a soft start for this table saw, but the table saw did handle that and it rebounded the voltage very quickly. So now let's try the 12-inch Hercules miter saw. Now this is the biggest one that I have. This has an inrush current of about 65 amps and a continuous current draw of about 9 amps. So let's again keep our eye on the voltage and see what it does. All right, so I saw a momentary drop down into the 80s. So again, it's acting kind of like a soft start, and the miter saw doesn't seem to have an issue with that, and it did fire back up, and we got back into the 117, 118 volt range very quickly. Okay, so as we saw, because this thing does have voltage throttling, this will give you a little more latitude with the types of power tools that you can run due to that high inrush current tolerance, because it does temporarily drop the voltage and bring it back up. So you can get away with a lot more power tools on this P280 because of that. Now, whether or not that is good for those electric motors, I am not the best person to ask. Now, if you're somebody who's got some insights on whether or not that temporary drop in voltage adds a significant or worrisome amount of stress on these electric motors, and you're willing to share that down below in the comments with the community, I'd very much appreciate that. I'm curious to get other people's thoughts on that. But yeah, I would say this definitely does pass the power tool test. All right, so pretty impressive performance, especially on the usable capacity test, with the DC outputs netting us an above average 84.5% and the AC outputs giving us a well above average 90% of rated capacity. And per usual, I did also test the AC inverter idle consumption, and I found that without any loads at all connected to the AC inverter and the AC inverter turned on, it will consume about 0.75% of the overall stated charge for every hour that you leave it on, up to 8 hours, at which point the idle auto shutdown will kick in to prevent it from running down any further. But if you do the math on that, that reveals that the idle consumption on this inverter is only about 15 watts, which is a solidly decent number for a 2800 watt inverter. Okay, so what are some things that maybe I don't like as well? Well, I would say there's not a whole lot to report in that regard, but one thing that I think I would mention that is at least a small nuisance is how the battery expansion port is located here on the same side with the AC outlets, which, as you can see, combined with these mildly annoying silicone port covers, it does make it a bit fiddly to get access to the outlets when you have an expansion battery connected. So you could obviously just remove those port covers, but I think it might have been just a little more convenient if they had located the expansion port over here on the other side of the unit with the other inputs. But like I said, kind of a minor nuisance at best. Now, I think that's especially so when you consider how AFERY is pricing this P280 right now during its introductory period. So using the discount code that they gave me to share with you, you can actually get the P280 either on Amazon or I think direct from AFERY's website for just $689, which is an extremely good price for a power station in this capacity class, especially with all the features that it comes with. And that works out to, I think, just under 34 cents per watt hour. And they do also, I think, have a combo deal, maybe on the website. I don't know if they do this on Amazon, but it's the P280 with one expansion battery for a total of 4.1 kilowatt hours of capacity for just $11.49. And that works out to only, I think, just about 28 cents per watt hour. That's even a better deal than it was on the P210 in terms of, you know, overall cost per watt hour. If you need that extra capacity, it's a pretty good deal. And per usual, I'll put all the relevant links and discount codes down below in the video description if you do want to go check out that and maybe jump on those launch event prices. Okay, I think that's a wrap. You know, I do try to also include a little informational tidbit here and there and some tips and maybe tricks in each video to kind of help you be a more informed buyer. So hopefully you found something in the video that I presented here useful. And if you did, please consider clicking that like button down below for me if you think I've earned it. Very much appreciate that. I also appreciate you spending some of your valuable time with me on this video today, and I hope you'll come back and join me for the next one. Until then, have fun out there.